Security features that we've added to both the Apache Cassandra open source product as well as the DataStax Enterprise platform. It's been said that NoSQL equals no security, as evidenced by the write-up in InformationWeek magazine, and by and large that's been true. There's been some amount of security, but really not much. What DataStax has done has come in and added security features to both the Apache Cassandra 1.2 version as well as the DataStax Enterprise 3.0 version, which we believe has brought security up to be production ready as well as enterprise capable, and dispelling the myth about no security for NoSQL databases. There are 4 categories of the security that we've added, the first being user authentication. This is a basic username, password type challenge when getting into the Cassandra database. This has been implemented through an API that customers can use to create their own authentication paradigms. DataStax has used this same API to extend the authentication paradigm for DataStax Enterprise 3.0 in that we've added Kerberos support for the whole product suite. The second section in security is permission management. We've created an interface where we've got users being given permissions for objects within the database as well as hierarchically through the system. And we'll talk about what those features look like. The third is data encryption. There's several tiers of data encryption, both in flight on the wire, between the client and the node, between nodes, as well as encryption on disk for data at rest. And the fourth is activity auditing. So we've added an interface so that you can capture audit logs on activities within the system based on the key space and the type of action that users are performing. So I'm going to break this up into 2 sections. The first is going to be talking about Apache Cassandra. And we'll go through those categories of security features that we've added. The second is going to be focused on DataStax Enterprise and the enhanced features that we've added to DSE 3.0 within the same category group. Much of it inherits from Cassandra, but then we've done a few things to add on to that. So the first one in Cassandra is user authentication. It's internal user authentication. The username and password is stored within the Cassandra database in a key space and column family. The permission management section for Cassandra is also stored within the database. It's based on the grant revoke paradigm and provides permission categories, object hierarchy. And we'll go into a bit more detail on this as we move forward. And finally, data encryption. There was already node-to-node encryption capability built into Cassandra before version 1.2. What we've added is client-to-node encryption capability. And we'll see when we get to DataStax Enterprise that we've also added on-disk encryption for the data at rest for the DSE platform. With DSE security, it's fairly similar. We've also got username password internal authentication, but we've extended that with external auth through Kerberos. The permission management is exactly the same, grant revoke paradigm, permissions, hierarchies, as we'll see. Data encryption on disk, we've added that to the DSE platform over and above the client-to-node encryption and the node-to-node encryption that you get on the wire. And finally, the auditing capability has been added to DataStax Enterprise. So pretty similar. You see the few lines in bold here are the enhancements that we've made for DataStax Enterprise over and above Cassandra. Sorry. So looking at Cassandra, we'll go through each of these in a little more detail. This is managed via the username password authentication, managed via the CQL3 protocol. Looking at the CQL shell interface, you can issue create user, drop user commands. Users get created with a password. Again, this information is stored right inside a column family within the Cassandra database. Users can be flagged as super users or non-super users. The default is not to be a super user, so that's an optional parameter if you're just creating regular users. Drop user is just drop user with username, and you can also alter the users with changing their password or changing their super user status. This is enabled via configuration files. Out of the box, it's configured to be allow all, so it's normal the way you would have expected Cassandra today. No authentication required, but if you change that authenticator parameter to be password authentication, users will then be challenged for a username and a password when accessing the database. And as I've said, it's stored within a column family off in the key spaces under users and credentials. Cassandra Authentication, moving on. Still with Cassandra Authentication. So the default user, when you open it up out of the box, it's the Cassandra user with a Cassandra password. This is a super user, and we recommend once you get up and running with authentication that you want to drop that user, create an alternate user with super user privileges, set your own username and your own password, and drop that Cassandra user. The data is also replicated within the system, so it's stored in column families, as I said, and it's got a replication factor 1 in order to support a single node instance where you bring up Cassandra with just one node, and you've got just replication factor 1 in that column family. If you're running a full cluster with, say, a dozen nodes or 4 nodes or what have you, you'll want to increase that replication factor. Replication factor 1 wouldn't be sufficient if you lost the one node that happened to be housing that data. What we recommend is the replication factor be equal to the number of nodes that are running in your cluster to ensure that all nodes have direct access to that authentication information. A couple of examples here. The first one is a user logging in using CQL shell but not authenticating. What they do is they run the CQL shell, that executes, it's just a client. And when they attempt to run commands against Cassandra, they will see a bad request that the user is not yet logged in. So repeating that command again, exiting the shell, coming back in and specifying the username and password on the command line allows the user to now see what the data is and actually connect up to the database. The password on the command line isn't optimal. You don't want people seeing that as you're typing it or having it be in your PS table. With CQL shell as a client, it's possible to create a CQL shell RC file, a dot file, and put your username and password in there and simply secure that file with appropriate permissions. Then you don't have to be entering the password on the command line. Similar interface would exist for other clients that you're using to access the system. They would be gathering the username and password in their own way. Another example here of creating a user. So the create user, Dave, with a password and specifying a super user. I then come in and can see that now there are 2 users in the list users command. Both are super users. And if I try at this point to drop the Cassandra user, I get an error. So we've provided protection in there so that you can't get yourself in a position where you have no user with super user privileges and thus can't get back into the system. In this case, you'd have to exit out of your shell, log back in as a different user, and then drop the Cassandra user. So Cassandra permissions, based on the grant revoke paradigm, the permission categories that we support include this list here. Create is for creating key spaces and column families. So given that create permission, a user would have the ability to create new key spaces or create the column families within the key spaces. Alter is for modifying those key spaces and column families, as well as creating and dropping indexes. Select is your basic read capability. Modify is for editing the data, insert, update, delete, truncate type commands. Drop will allow you to drop key spaces and column families. And finally, authorize gives you the ability to grant permissions to others. And we'll look at this in a little more detail. You need either super user privilege to grant users permissions, or have an authorized permission with the permission you're trying to give to another. This allows you to actually delegate administration for whole key spaces, for example, to a particular user, give them the authorized permission, and then they can grant permissions to others within that key space. These permissions are hierarchical, so there are actually 3 tiers. You can grant permissions at the top tier for all key spaces, and on down. So if I had that permission, I could create any key space, create any column family within any key space, given that permission hierarchy. I can also specify permissions on just a key space a specific key space. So I could, for my very own key space, have permissions there and not have permissions in the rest of the area. And you can also get down to the column family level with table. These permissions are also individual. Interestingly, if I had permissions to, say, read a column family within a key space, and I also had all permissions on all key spaces, removing all permissions will not remove my column family permissions. That's a separate permission that may overlap with the one I've got at the column family level, but removing from the top is not a recursive type operation. So all those permissions are individual. These are enabled via the Cassandra YAML file. There's an authorizer keyword. Again, out of the box, it's wide open, so allow all. Allow all authorizer is the default setting. You'll want to go in and set the Cassandra authorizer, and that will enable permissions. By default, no users have any permissions. You'll then need to start granting permissions to users for them to actually gain access to the system. The CQL interface for doing that is the grant and revoke commands. And you can grant on keyspace, on keyspace.column family. You can grant to a specific user, and you can select the different permissions that you want to provide to those users. This requires super user privilege, and as I had said earlier, you can also do it if you have authorized permission. So if I have authorized permission on, say, keyspace Dave, and I want to give permissions to other users to my keyspace for them to, say, read on that column family within there, I would need to have that read permission in addition to the authorized permission. So given authorized plus the permission I'm trying to delegate, I can then give that to other users. And again, this is all stored within column families inside Cassandra in auth permissions. So a couple of examples here. I'm creating a new user and granting some permissions to the user. Create a user Mel with a password. It's not a super user. That's an optional parameter there. I can then try and run list all permissions, and I can see that the new user has been created, but there's no permissions for that user. So by default, when you create a user, they have no permissions, can't read or write or perform any operations within Cassandra. You would need to then grant them permissions for them to have the ability to do anything within the system. So here I've granted select on a table in airline.routes and granted modify. Now when I run list permissions, that's showing up at the bottom. Mel has 2 permissions on those individual column families. The user Dave actually also has some permissions. I granted select permission on all key spaces. That's actually redundant in this case because the user Dave is a super user in this case, so it would have those permissions in any event. So a couple more examples running as the user Mel. If I now log into CQL shell as this new user Mel that I've created, I can run a select command, select star on airline routes, and I get to see that data. If I try something else, say select star from airline.airports, I cannot read that data as the user Mel as I have no permissions on that column family, and I wasn't granted permissions on the key space. I was granted permissions down at the column family level. Also, list all permissions is not available to that user. Pardon me. So moving on to data encryption. Within Cassandra, there's 2 forms of data encryption. Both are in-flight on the wire. It already had node-to-node encryption. This was the ability to encrypt information between the nodes in the Cassandra cluster. There's now the ability to encrypt data from the client to the node as well. And there's configurations for node-to-node encryption that you can configure encryption for communication between all nodes in the cluster or just nodes in remote data centers. So I might have my local data center as secure, but if I'm communicating to a remote data center, I might want to encrypt just that communication on the node-to-node setting. And I can also do the same thing at the rack level. Sure.
Is that a feature of Cassandra 1.2 or just the DataStax waiver?
No, this is all Cassandra 1.2 that I'm talking about right now. Yeah, I'll do all DataStax Enterprise after this. So everything so far is open source Apache Cassandra that we're talking about. I had a comment there, but I've forgotten it. Oh well. So in flight, this is configured in the configuration files. There are 3 different settings that you configure for in-flight encryption capabilities. The first is the SSL storage port. This is set by default. It's really not used until you enable either node-to-node or client-to-node encryption. That port is just idle. When you modify the encryption options section, again, you can do internode encryption and set it to none, which is the default. We can do all for all nodes should have encrypted communications between them at all times, or look at DC or rack settings. And then you have to set up the key store and trust store. This is the node's certificate key that gets stored on the node, as well as the trust store is the nodes that this node trusts to communicate with. The same sort of setups exist for the client encryption options, for client-to-node setups, where you can enable this and then provide the key store and trust store for those settings as well. All right, so that was all Cassandra, Apache Cassandra 1.2 open source configurations for security. We'll now go through sort of that same list for DataStax Enterprise. Much of it is the same. Internal user authentication. This has been backported from Cassandra 1.2 to the version of Cassandra that we're running within DataStax Enterprise 3.0, which is 1.19. DataStax Enterprise lags the Cassandra open source version by a little bit. We do testing, certification, qualification on the version of Cassandra. Sometimes we apply patches to that version to get an enterprise-ready, production-ready version of Cassandra. And we've now taken the 1.2 features for security that we've added to the Apache open source project and backported that to the 1.19 release that's inside DataStax Enterprise 3.0. Again, users can create their own paradigms, and we've created an authentication paradigm based on Kerberos. Kerberos is available already in Hadoop. There's also a web Kerberos interface for Solar that we'll see. So we leverage that capability down into DataStax Enterprise, and through that we have support for LDAP. Kerberos supports LDAP. We do not support authentication directly to LDAP as a primary authentication mechanism within DataStax Enterprise, but you can link with LDAP through Kerberos, so get that by extension. It's something we're looking into in the future. So authentication, Kerberos support for the tooling. So primary Kerberos support for Cassandra, of course, for CQL shell, for our Cassandra client, Scoop, Thrift, et cetera, all of these clients are able to be authenticated through Kerberos. We also have Kerberos delegate support down through Hadoop, the CFS, Pig, Hive, Mahou type setups coming through that interface. For Solar, it has its own Kerberos authentication at the web UI level, and since it runs within the JVM along with Cassandra in the DataStax Enterprise process, there's no need for that to be handled. No need for extra auth there for Solar commands and queries, data ingestion or searching. And finally, JMX. The JMX interface has not yet been modified to handle these new security features, so it's still secured through its standard JMX methods. A little bit on Kerberos. Kerberos principles, admins only required for managing a key server, which is not yet available through us. That would be something you do with a third party, like say Kazang or someone like that, to do a key store. At present, we are storing the keys on the node, which is something to be aware of. The DSE service principles, there'll be one per node, and the format is there, either HTTP or DSE with fully qualified domain and realm. And regular users get username at realm, and that full principle must exist within the authentication space inside Cassandra. So when you're authenticating through Kerberos, you need to also create the users within Cassandra. No password is provided. That authentication comes through Kerberos, but the users do need to exist in the system, and they need to be the full name, username at realm, which is the name being used for the Kerberos authentication. So DSE permissions, no change here. This is exactly the same as with Cassandra. The same hierarchy, the same list of categories and permissions that we talked about a few minutes ago. And DataStax encryption. Again, very similar to Cassandra. We have client-to-node encryption, node-to-node, and we've added on-disk encryption that protects the data at rest. In this case, we are actually encrypting the data within the SS tables. As we flush from mem tables to SS table, we encrypt that data and write it on disk. So now you have the capability to encrypt data both in flight and at rest on the nodes. We are not at this point encrypting the commit log data. Commit logs are ephemeral. So as we write data into the Cassandra database, we first append to a short commit log. We write to mem tables. When those mem tables flush to disk as SS tables, the commit log gets erased. So the elements that are in that commit log go away. So the commit log, again, is ephemeral data. It doesn't last that long. And at this point, we are not yet encrypting it. That's something we're planning for the future. In the meantime, again, you could use a third party, something like Kazang, to do a partition file system encryption level for that data if that were essential for you. And the same thing for the key store. Since the key's on the node, some people view that as a security risk. If someone were to come in and hack the node, they could actually gain access to the key and thereby use that key to gain access to the data. So again, something like Kazang could be used as a key store or to encrypt a small partition where you put the actual key. So the configurations for this, same thing as with Cassandra, setting up the SSL ports and the encryption keys. On disk data encryption, this is enabled on a per table basis. So we're encrypting data per table. You can decide you want key spaces and individual tables encrypted. The configuration is with the alter table command. We've leveraged the compression algorithms that already exist within the Cassandra database, and we can now specify an encryptor in place of or in addition to, as it turns out, the SS table compression setting. So in this example, we're just setting the compression to be encryptor and specifying the secret key length. We can also do both at the same time. The second example here shows that the compression setting is for encrypting snappy compressor. This is doing both encryption and compression. We're setting the cipher algorithm in this case and the secret key strength. There's actually a number of different compression algorithms we can use, which I'll show in a moment. One thing to note is this does not encrypt existing data. So if you upgrade to DataStax Enterprise and you want to encrypt your data, when you enable these features, all new data that gets written to the system will be encrypted and written down to the disk in the SS tables. If you want to encrypt the existing data that's in SS tables already existing on disk, you'll have to run something like DSE tool scrub to rewrite those SS tables, and at that point they will be encrypted. So encrypting compression options, we can do just encryption by specifying encryptor. We can do encryption and compression with two different compression algorithms, or you can just do straight compression, specifying one of those two algorithms individually. And the encryption algorithms that you can use for the way that the data actually gets encrypted include these here in the list: AES and DES, Blowfish, RC2 with different secret key strengths. And finally, DSE auditing. So we've enabled DSE auditing via the log4j config file. The output for the audit can be written to a log file on disk, and that gets specified in the log4j server properties file, or it can be written to a column family within the Cassandra database again. The formats for the log are all pipe delimited with fields. These are key value fields, so you actually see the keys within the output. I'll show you an example of that. But these different fields include the host, which is the DSE node that has received the activity and is logging this audit activity. The source is the client address, the node that initiated the request to drive this activity. The authenticated user is added with the audit log line that comes out, as well as the timestamp for the event when it occurred. Finally, the category of the type of audit that you're seeing is the type of activity that you're seeing is included within the log line output, DML, DDL, etc., DCL query. The type is the API level operation that's occurring down within Cassandra. And when you're running CQL commands, we actually show the operation, the CQL command that was issued in addition to the type, the API level command that was the activity that was being logged. There's also optional information on batch and key space and column family information. So if you're creating a user, for example, there'll be no key space or column family data. If you're writing data to a key space or a column family, you would see both the key space and the column family data written on that log line. So these are just optional parameters. The audit categories that are include auth, which logs all login events. We've got DCL, DDL, and DML categories for the different operations on grant revoke, drop user type operations, the create, alter, and drop events for the data, definition, insert, update, delete type operations for data modification, as well as read events for query, admin type operations, or you can specify that you want to log all audit events. This could be a comma separated, a comma delimited list of categories can be included, and all just overwrites that whole list. Audit configuration options. So the first release here, there are 2 audit configuration options. The first one is by action, so you can audit and limit the audit that you output to the log file based on the type of category, the audit category, the DML, DDL, etc. You can limit by key spaces, so you can specify key spaces or blacklist key spaces that you don't want to see auditing information on. And in future releases, we will include configurations based on the user, the object, the error type, and column information. That's not yet available in the 3.0 release. So configuring this stuff, again, is by the log4j server properties file. You come in and set the appender to be the appender file, to be specify a file on disk where you want to write this data. You can then go in and set the default audit level. Info is the default and probably the one you want to keep with. If you go up to higher levels, say, or lower levels rather, say for warning, you won't see any output. You'll have the audit logging enabled. You'll see that modest performance hit on what happens when that code gets run, but you won't get any outputs because it requires info level to get the audit logs to be written. And finally, the active categories. And similar here, this should be a non-empty list. You need to specify the categories that you want logged. If it were empty, there would be no categories logged, and you'd be suffering the overhead of driving that code without actually getting any output from it. So a couple of examples. This is a CQL command, issuing the use command on a key space, DSP904. You see the first parameter is the host. This is the node where the activity occurred. The source is the client that asked for this activity. The user, the authenticated user, is listed, along with the timestamp of when this action occurred. And the category, in this case DML. The type is the API level command that gets issued, set key space. And since we are operating on a particular key space, it includes the key space parameter, KS DSP904. Finally, with CQL commands, you see the operation string, which is the command that was issued from the CQL level that drove that API level type command. As a Cassandra CLI level, the same command being issued. Really the only difference here is that you do not see the operation field at the end of the line. It was just driven from the Cassandra CLI, which is really an API level and no CQL on top of that. Another example for CQL query or drop key space. Again, each of the values is entered delimited by pipes. There's a name, colon, and the value, and pretty straightforward to read this. So, in summary, we've added 4 different kinds of capabilities for security. We've added it to both the Apache Cassandra open source project, and we've added to DataStax Enterprise. There's a few more features added to DataStax Enterprise around encryption on disk and authentication for Kerberos, a couple of other things. But these are the main categories here. User authentication's been added, permission management on the grant and revoke paradigm, data encryption through client to node, as well as node to node and on disk, and finally activity auditing. Can you go ahead, a question?
Yeah. So Cassandra 1.2 adds schema introspection in the system space. Are the permissions for that managed by what key space you're asking questions about, or is it just treated as any other key space that I have to have permissions on the system?
I actually don't know the answer to that question. That's a good question. I know that when you're doing sort of described schema, that has changed now. You're not getting the full output that you used to get. That's based on permissions. And I don't know if system is treated as a regular key space. I think it is slightly special, but I'd have to get back to you on that. All right, come afterwards. I'll talk to somebody else. We'll get an answer for you. Okay? Yeah? Yeah?
This is sort of related to the question that was asked. Can you get row-level security? Can you plug in row-level security?
No, there's no row-level security. That's a good question. I actually was asked that upstairs as well. I can't quite see who that is. Maybe that was you. Somebody do, oh, there you are. Yeah. The security is down to the column family level at this point, but we will be rolling out enhancements to this. Probably the best approach is to log an enhancement request and talk about row-level security, and we'll see where we go from there. Okay? Yeah?
Since the permissions are being managed in the same column family, what if there are conflicting changes on people trying to both permissions of different users?
So, depending on the read, I don't know what the read consistency level is for authentication. I know this information gets cached. There's a parameter for setting that cache timeout, and we recommend that you replicate to all nodes in the cluster. I imagine it would be handled the same way that normal collisions are handled within Cassandra, with a higher consistency level and resolving to the newest timestamp. But again, I don't know that level of detail. So
It's theoretically possible to have two users revoke each other's super user access and end up in a situation with
I guess if you try hard enough, you could definitely lock yourself out in that case. But we'd have to find out if there's protection for that. I don't know the answer.
Can you repeat that question?
Yeah, I'm sorry. The question was on consistency level for reading the user authentication information. Could two users drop the super user at the same time from different nodes and have that data not show up so that you actually lock yourself out?
With the data security of this, is there any performance implications to that?
There is performance implications on that. I don't have hard numbers on that. We're still working on all the benchmarking. It seems to be sort of in the area of 10%, but I can't really quote hard numbers as to say we know what it is, we've benchmarked it and studied it. That analysis is being done today. Okay? Hang on one sec, this guy. No, there's no group or role-based security in the permissions module today. Again, that's something on the roadmap that we'll be adding in future releases. This is the first release of all these security capabilities, but that's something we're looking at for sure. Oh yeah, sorry, go ahead. Yeah, you would edit the YAML file for all the nodes and then restart those nodes and then bring your clients in. So we recommend doing it all at one time. Now, if you were doing, say, a rolling restart, a client would come into a node where it would have to authenticate and another node where it might not have to authenticate. So we certainly don't recommend that you have mixed mode. You would have all or nothing. And during that restart period, you might have, some people getting in and others not quite. But you would tend to do that all at one time. Yeah, sure, go ahead.
So, it seems that the authorization is managed by some configuration part. So, it cannot be managed with the configuration.
So, I'm sorry, I didn't quite hear that. Start again?
Authorization is managed by the configuration part, right?
Yeah, for turning it on or off.
Okay. So,
Yeah.
it cannot be like, the super user cannot run the permissions via the command line. He has to go to the configuration file and modify it.
No, so authorization is username password to gain access to the system. Then permissions, again, is configured in the YAML file, but once turned on, all of the configurations are done through CQL shell or CQL3, right? So you go into the system and then issue commands to grant permissions. Say, give Dave read permission on the airline key space, right? That's not done from a file, that's done from the database directly. It's just the enablement of the permissions or authentication is done through the configuration file, and then you restart the node. Okay, sorry, you were trying.
You have to know that actually you are configured for your one
Not at this time. So what I had said was the auditing by categories. We have a list of about 6 categories that we're driving for. Only 2 of them were implemented in the first pass. So by user is on the list. We just didn't get it for the first pass. But that will be coming. Yeah. As well as some others. I mean, I could go back and show you what that list looks like. Here we go. Whoop. So by action, by key space is available in the first pass. By user, object, error type, and column, that's going to be in a subsequent pass. That's through this Log4j server properties file, the way you configure the vendor, sort of the standard Log4j kind of interface. Question over here? Oh, are all these commands available in the CLI? No, it's CQL3. Yes, only CQL3. Yep. Actually, I can't answer that question. I don't do product direction. I know that we're working on our product roadmap, sort of revisiting it right in this time frame right now. We periodically, of course, revisit our roadmap. I'm not really sure what those discussions include, but they'll be coming out with a new roadmap, and ultimately I'll get to see that. I wouldn't imagine Kerberos going to the open source project. It's sort of a Fortune 100 kind of thing in most cases, but I don't know. You could contact us once the roadmap's established, and we can let you know what the situation is on that. Okay? Other questions? All right, well, thank you very much.